Good morning, everyone. I welcome you to the talk series CS Katha Barta, where we invite academics and professionals to deliver their talks. Our guest for today's talk is Dr. Abhishek Singh. Dr. Singh holds a PhD and MTech from IIIT Allahabad, specializing in semi supervised machine learning. He has over a decade of industry experience. His work focuses on assessing real world problems for AI ML solutions and designing scalable architectures. His research interests include semi supervised learning, FAT ML, CNN, RNN, transformer, generative AI LLMs, and multi agent system. Today, he will be speaking about multi agent RAG. I welcome you, Dr. Singh, and I invite you to take the virtual stage and begin your presentation.
Thanks, Dr. Richa, for that lovely introduction, and thanks, Dr. Shubhankar, for organizing this CS Katha Barta. I have gone through multiple series which are available online, and I'm delighted to be invited over there on this platform to present a talk like this. Hello, audience. Today we will be looking into the multi-agent retrieval augment generation. This is one of the most cutting-edge technology that all the tech companies are being hitting right now. Right, retrieval augment generation we already know has been very popular among all the solutions, the Gen AI solutions, the LLM solutions, and then there is a new child in the corner which is called agentic and multi-agentic framework. So today I'll take you through the roadmap of how these things work, how they merge together, and they create a very unique solution out of it, right? Uh, this is our roadmap for today. We will be seeing AI agents into the action, what AI agent means, how they are useful, and why they are useful, how they shall be used, and what are the technologies behind it. Then it will be followed by a brief concept of how retrieval works, though you have got various knowledge base and all those data sets. But then retrieval is a key step to any kind of AI ML solution that you provide. It is followed by concepts of generator, which is again a very unique, very important concept in modern era of AI ML solution, wherein you just not retrieve or just not say whatever has been trained on the model, but it surely creates some kind of human understandable form of text or speech or images in today's scenario. And then we will go through the series wherein how this retrieval generator, both the modules can be merged together to create a RAG architecture. And then we will combine all the concepts that we have understood till now to create a multi-agent framework. As a bonus, I will try to take you through the route of the current working area for multi-agent framework, which is MCP, Model Context Protocol. Nowadays, everyone wants to build out MCP for themselves, and we'll look into it, what it is, and maybe you can find some opportunities to have your research work, some research papers or patents published over there. Let me bring you to the thing of AI agents introduction. Uh, we all know that every AI ML technology that we build, it tries to do everything by themselves. It's like every task is being assigned to the same model. But now with AI agents into the scenario, we can think of it like it could be something very specific. A very specific task has been assigned to those agents, like how a human should have been working, right? It's like how we go to an orthopedic if we have got some problem into our bones rather than going to a general physician. So here the agents, they are signifying very specific tasks that they have been designed or aimed to be provided, right? They do not go for the generic task that we have created for any AI ML algorithm, but they are very specific to what we have been designing. So if you see over here, the general purpose AI agent, it includes some kind of tools which are being exposed to the agent, and then it works on various kinds of inputs from user, which leads to some autonomous action. it also have a memory wherein it can hold in the actions, the responses, whatever it has done in past. And probably if there is some task which is beyond the agent's capacity, it can also delegate the task to other agents. It's similar to how human would have behaved in a scenario, right? And then we should be looking into how AI agents come into the picture. So imagine you are on a supermart purchasing something out over there, and then you have got a very smart agent who is able to pick out these specific items from your list. So you don't have to search it around. They are able to identify what are your needs from the checklist, and then they are supporting you uh, for your speedy work, right? So we can define the AI agents like it's a piece of AI which has been designed to do a specific task, and they do it by perceiving the underlying environment and take the appropriate action based on whatever inputs and whatever specific tasks or goals they have been designed for. These tasks helps them to achieve that specific goal. An example, nowadays, if you go to any of the websites, maybe I was trying to do some kind of thing over the MyGeo app for my GeoFiber router. So there was a chatbot who was prompting me that are you having this issue? Then do this, do this. It's like having an enormous source of information collated with one agent, which is able to specifically produce whatever the need of R is. Or you can think of some kind of automation wherein it is able to automatically identify which emails are of utmost importance to you, or which emails are from the spam category and they should be filtered out from your email box. It can also be think of an AI agent or a model which can help you schedule your meetings automatically. So supposing you have got birthday of your friend, and you always want to have a dine out reservation in evening, then this AI agent can help you find out the best place which is as per your budget, as per your requirements, the ambience and all those things, and then automatically go through the process of various IVR request response or maybe a REST API call, and then do a reservation themselves. So it seems very nice on the front that everything that you want to do or achieve in your life, you can actually get it transferred to some kind of agent, and then further this agent based on the set of tasks or goals, they can design their own set of actions. The key takeaway from all this background information for AI agent, it would be uh, the AI agents are being created with a purpose, right? Without purpose, these AI agents are as good as the normal model that you create. If they haven't got any specific roles or specific goals, then they will not be able to perform any kind of task that helps you get your task doing better, right? So they are very focused, they are very specialized, and they are very helpful. Now that we have already been able to understand that how AI agent looks like, or what is the role of AI agent, then let's move forward into the other aspects of today's talk, which includes the retrieval portion, right? I have utilized an image over here which includes multiple books out there, and then you have got a magnifying glass. The magnifying glass is able to identify the various data points that are looking looked into these books, right? So you can think of these books as your knowledge base, as your data sources, and then these magnifying glass are the retrieval process which is able to identify and extract the accurate information that you require. Think of it like this: we all are in phase of research, right? I mean, the audience is from PhD, so you might want to do a research work by starting with reading a research paper, understanding it, recreating the scenario, and then reproducing the effects with some enhancements on top of it, or maybe you are able to identify some issues, and then you are trying to get it solved through your model or your method, right? And finally, the outcome of that will be a well designed, well written research paper. Now we all at this PhD level, even me, or maybe if Dr. Joshi and Dr. Mishra can vouch for it, they have done the same stuff. We try to do everything by ourselves. We try to select out the papers, read them out, try to understand, try to recreate everything by ourselves only. But that should not be the way, right? I mean, I may be very useful at recreating a scenario, but I may not be very good at writing a research paper, because it requires some kind of mathematical expressions. Then it should be very concise English phrases, wherein you can express more of the content in minimum length, right? So there could be some specialized person, maybe I can think of my PhD guide, who can help me out with writing a paper. When I produce some stuff to him, he will be able to look out what are the things that require some kind of changes, and the paper would be in such a state that it's most of the times are acceptable to the publishers, right? Now this is the same thing that Retrieval is trying to get it done. It tries to give out the relevant information, which it is very specific and specialized at, through multiple data sources. And this is certainly very different from what has been trained to a model. So there is a training phase of model, wherein if you ask a question, it goes to that training portion, and it gives you the outcome based on that training portion only. But here, instead of going or referring to only the training portion, it can actually refer to the real world data set, real world knowledge base. And then it can produce some stuff, or it can accumulate some stuff wherein it's realistic. As we call it in the terms of GenAI, LLMs, or the modern AI technology, it's called hallucination, wherein the models try to make things up. I mean, there is something imaginary. But with retrieval at place, this hallucination is minimized, because you are referring to the actual data sources instead of making things up, right? Now, the next question that you will be asking yourself is, though retrieval is the task of identifying the information from a knowledge base, why do we need retrieval? So it's the same thing, right? As I mentioned, instead of the model going through the data, the training data through which it tries to remember, it actually retrieves the data from actual data source, right? So here I have put in example wherein the user query could be, what is the highest mountain in the world, right? And with training data without a retrieval algorithm in place, the model will try to take a closer look on the training set only. Now, it can give you some information which may be outdated, which may be incorrect as well, and it could be even a wild guess, or it could be a hallucination wherein there could be no mountain named Alka Lama, and then Alka Lama is pushed as the highest mountain of the world. So that's hallucination. But with retrieval in place, it will go ahead, it may be able to search it out on various websites which are available, like your Wikipedia, or maybe referring to some kind of encyclopedia, or maybe referring to some kind of textbooks from geography department, right? And then it will be able to answer you the appropriate mountain which is tallest by looking at these new data source. So now we are moving our model to be dependent on just the training set to a much larger knowledge base, wherein the answers could be supported with some evidences. This actually highlights that retrieval is the key, wherein it makes the AI more accurate. It also, through its instance of having evidence to each of the results, it makes it more reliable. And then it's less prone to hallucination, which is just making things up, right? Now we should look into, if we have got retrieval and we already have gone through why it is important to have retrieval. Now we should also look into the piece wherein how retrieval can be implemented on top of my knowledge base. And pardon me, I couldn't say it before I started, but it should not be a monologue. It can be a dialogue. So whenever you have a question, please interrupt me. Please go ahead, ask the question while I am looking at my screen on the slides. You can go ahead. You can ask any kind of question intermediate in between the presentation, right? Now, with this retrieval, how retrieval is being applied, the first thing that we do is a normal keyword based search. We all know how keywords work, right? So, supposing you have given some search query to your retrieval agent, and then this retrieval will try to match this keyword among all the data sets that it has, right? It may be somewhere very similar to how a cosine similarity is being matched. You take a keyword, you do encoding, a vector encoding of that keyword, maybe using any kind of sentence transformer, or if you are using very simpler method, you can use a TF, IDF, or maybe a bag of words as well, right? So you do a vector encoding of your search keyword, and then you go and compare a cosine similarity with all the keywords that are available on your knowledge base. It could be a vector store as well, right? Once you have been able to identify which of the data source that are available within your framework is matching more accurately with your search keyword, you will just pick it up and you will give it as an answer. Though this is very simple, very effective, and very efficient to use, but it may not always lead to an accurate answer, because the search, it just not depends on the keywords, right? It depends on something else. It may depend on the context of that content, right? I mean, what is the meaning of the search query, correct? From there, the model has shifted to the semantic search, wherein instead of just relying on this similarity score search or the keyword search, we go ahead and we try to find out what is the semantic similarity from your search query to original data set, right? It means it just not tries to find the cosine similarity between the two vector embeddings of the words, but it also tries to find out what is the meaning of the search query and what is the intent of my whole vector database, right? It is more sophisticated than keyword search, and then it tries to identify what are the more relevant sources from my data. So it's like in the first one, if I can give you an example of keyword search, it's like you are visiting library, and based on your area of research interest, you are trying to pick out the research papers or books which are having that keyword, right? But instead of that, you could do it more accurately, more precisely, if you could go to the librarian, and the librarian has information about all the books and all the research articles which are present in library, and they can suggest you the best article, best book which aligns with your research interest, right? Then there is another kind of model on retrieval, which is factoid question answering, which is an advanced level of semantic search. It's not just being dependent on the understanding of the query, but it also try to reason it out. If there is a question, then it will try to reason it out, that what is the intent of this question and what could be the possible answer of it. So it's like you are asking some factual question: what is the capital of France, which is not going to change from what is here to in the next whenever the data is refreshed, right? So these are factual questions wherein this factoid question answering models can be utilized. Now that we have looked into the various aspects of retrieval, like what is retrieval, why it is important, and how to achieve a retrieval in your model, right? Now we should also look into what are the advantages of retrieval. So as we have covered the whole topic, we can summarize it in a sense that if we use retrieval, it's more likely to produce an accurate and precise responses based on the accurate knowledge base that you have, right? It is less likely to hallucinate, so that the user content is always the content produced is always relevant to the user query. And as this AI systems are becoming more sophisticated, the importance of retrieval is going to grow, because it's not possible to train your model with each new data set which is coming in. Now, we have covered the topics of AI agents. We have covered the topics of retrieval. Now, we will also look into the topic of generation, and it will be going into the same series. We will go through the introduction. We will ask the question why generation is required, and we will also ask the question what is generation and how it should be applied. Then we should also look into the various advantages of this generation, right? Now, see, this is a kind of generation model that I could think of. It's a mimicking of what the modern era ML model looks like, wherein various data sources have been plugged into a retrieval network, and then the information is provided to your generation, wherein it could curate what is the relevant information that the user requires, right? So first, let's see why generation is required. In retrieval, the data that is being extracted out of your knowledge base, it remains raw, which means that they are not curated to speak a personal kind of human touch to the user, right? And they may not be able to make sense in their raw format. So they require some kind of polishing. Now, generation is the process through which the polishing of the retrieval or the information can be done. The generation, it takes in the information from your retrieval, and then it crafts it into a human readable text which is more likely to have acceptance across the user base. Now, it's very similar to how a chef would take in various ingredients like the raw vegetables, the spices, oil, and all those things, and then it can cook up a nice looking dish which tastes well as well, right? So it's the same way how AI tries to cook up conversations, which means AI is able to identify what should I be giving out to user which is of utmost interest to it, right? Now we should also look in what is generation. So it's not just about randomly picking out some words and stringing it together and producing it to user. The words that come together in this generation module, it should always make some sense to the user. This is being done through various information which comes through the retrieval network, right? It could be understanding the context, which means that what is the query, what was the user query, which direction it was asking, by retrieving the meaning of it. Then structuring the information, which means that you have to have curate all the facts and ideas together in a logical series so that it's able to curate a better answer to the user. It should also go through some grammar and syntax checks, and through polishing of it, because the semantic and syntactic of that sentence should make sense to the user. The other way to put it up is it should be able to choose in the right words which are more informative to the user rather than creating a confusion out of it. And then within the multiple sentences that the generation module is going to generate, it should be able to create a generic flow across all of them, and it should make some sense as well. So it's not about picking out some words from somewhere and putting it together and throwing it to the user. It's always about to create something which is meaningful and relevant, and it should be making sense to the user. And that's how generation is being done. Now, how to do a generation? Generally, you can think of something like a rule-based generation, wherein you have trained a model. You can ask that, see, this is the English grammar. It goes like subject and then object and then some verb, right? And the model can try to predict out words from the given vocabulary based on these rules only. This is very simple to use, but then it can be very difficult because it's going to be repeatable. It's going to be predictable, which means the application which is utilizing a rule based generation, it may be giving you out the same kind of text again and again. So prior to the current era chatbot applications that we have seen across the help applications, they were doing some kind of rule-based generation, wherein they have got very specific set of Q&A curated into a DB kind of thing, and then based on the keywords that are matching with it, they dump in the original text to the user, which was sometimes making sense, but most of the times they were not looking for the solution which was being proposed over there. Then the advantages of rule-based generation. It is predictable, it is good for structured output, and it is very simple and effective to use. But there are some disadvantages to it because it's more predictable. You are no longer being very intuitive to identify, I want to talk with a chatbot. And then it lacks the creativity and flexibility. Then there is something called statistical generation, which is actually the language models, just like how you may have designed a sentence transformer, right? So you try to learn the patterns of your text and then try to predict out what is the word which is making more sense. So nowadays, if you go to any LLM and you type in that, give me explanation of some ABC concept, maybe of the celestial body concept, the stars, the moons, and all those things, and you type in, give it in such a way that it can be understood by a 6-year-old kid, then the LLM model, the model itself, will be able to predict out which words is more suitable to that age group, rather than putting out the helium and hydrogen, these kind of concepts. It will simplify it so that a kid of 5 years, 6-year old can understand it. And that's where the statistical generation concepts comes in, right? So it's like the example written over here, which mentions that modern large language models, the LLMs, they use these specific techniques and they predict the next word based on the words that have come before. So through all LLMs, it is very simple. You have got words till certain point, and then you try to pick out the probability of next word. What should be the next word which should be aligned to this, right? This is how all the LLM works. Internally, they use transformers, which again internally use an attention network, right? Which is very widely used concept across all the LLMs. Then there are some advantages to it, which means that if you talk with an LLM, it will sound more human rather than being an AI model or a robotic voice, and it can handle more complex and creative context of data. It has got some disadvantages also, right? It's very heavy model. It runs on various wide resources. It consumes more power, and then the factual grounding of the content, it may be lacking sometimes, which may be harder to control. And that's why if you go to most of the LLM models today, you will get something like a hyperparameter like a seed or maybe temperature to be set out there, so that your model does not hallucinate or make things up, right? Now we have understand what is generation, how generation is used. We should also understand where it should be applied. So whenever you are looking to build an application wherein you are interacting with an end user, and user is expecting some kind of human response like a help assistant, then you should be utilizing this kind of generation module. It should not be a rule based, it should be something on a semantic base, right? Then if you are trying to have your research paper summarized through these models, then generation module can be used. A simple chatbot having an interaction with the user, their generation can be used. And finally, there could be a trick to it, but if you want your research papers to be written by some AI model, then generation can be used. Now, the key takeaway from generation would be it can text in information and make it more useful and accessible to us through the language that we understand, right?
Dr.
Now,
Abhishek,
we have covered in the major topics of today's talk, which is agents, retrieval, generation. Now, we should know the power of combining the retriever and generation. How do they work together? Retrieval, as you know, it's the idea to find the relevant information from a knowledge base, right? And then generation is to create a language or to to create a sentence which is more understandable to the human, right? In between, there is a concept of augmentation, which is enhancing the generative power by creating some augmentation to the data that is provided, which means the information that is coming from your retrieval will be somewhat augmented so that your generator is able to generate better sentences which are more understandable to the humans. It can be summarized as AI retrieves knowledge, it enhances the text generation with factual grounding using augmentation, right? Why RAG is required? So retrieval, it takes data from various sources. It may be very meaningful to the user, and generation could generate the data, but then both of them together will create something which makes more sense, right? It will be like if retrieval is running in silo, generation is running in silo, you are providing some information which is taken out from retrieval to generation, and then generation is generating something. Then the factual things that generation might have required to put as an evidence, it might be lacking into the output. By combining both of them, you are actually trying the generator to identify what information retrieval has provided to you, and if there is certainly some additional information which is required to generate a more specific or more understandable subject out there to the user. The merger of both this retrieval and generator, it can make an AI first go and find the relevant information and then use that information to craft the final response. In a nutshell, this is called RAG, which is retrieval augmented generation. Now, there is no rule of thumb to provide that there is a single architecture of RAG. There are multiple architectures of RAG and there are multiple variations of it. A simple RAG would be if you want to get some tasks done through your model, you can ask the model to break it down into multiple simpler atomic tasks, and then each task can be done at once, and then the combination of all the output could be put out as a final output. This could be a RAG architecture. The other RAG architecture could be more complicated, wherein there could be a knowledge base. You go ahead, you search the knowledge base, you pick out the relevant information, then you send it to a generator, and then generator is able to curate the final response out of it. Now, where we have understand that what is RAG, we should also understand how RAG works. So this is a typical example how RAG works in an application, wherein a user asks a question. Suppose I ask in what is vector store. So the retrieval engine kicks in, and then retrieval will take this search query, try to find an intent to it, try to search out all the knowledge base which is available to its disposal, and then with the help of all the retrieved information, it will try to kick in the generation step, wherein this retrieval information is coupled up with the evidences that it has been able to form, right? And then it goes ahead, it tries to generate these sentences or create these sentences which are syntactically correct, grammatically correct, and is able to make more sense to the user query. So if I have asked what is vector store, it should be able to give me like a definition of vector store. Vector store is a NoSQL kind of data wherein you can store your data in a vector form, and various algorithms like cosine similarity, KNN, these kind of algorithms are run on top of it, which tries to identify the data which is similar to your data. Now, it should always be able to give me some kind of example, like what are the different examples of vector store? Maybe ChromaDB, maybe Pinecone, maybe the Elasticsearch, maybe the Redis Enterprise. These kind of answers should be also present over there. Though I have fired a single query, what is vector store? But I'm expecting my RAG to give all these relevant information to me, and maybe it should also curate in some kind of example as well, like a sentence converted into a vector form and then how it being stored in a typical vector store, right? This is what, and this is how the RAG works, right? Now with this engine's retrieval, then the relevant information, and then the generation, the AI tries to give an answer to the provided query in a more natural way. Now, what are the advantages of RAG? Obviously, it improves the accuracy by taking in the relevant information from retrieval based on the evidences that it has got. It reduces hallucination. The the thing wherein the AI scientists are most afraid of in nowadays is hallucination, wherein the AI model is trying to create some stuff on its own through evidences that has been provided based on this retrieval engine. It also ensures you can trust the AI model from which you are taking the information, right? Nowadays, the developers no longer go to Stack Overflow or some other threads to find a solution to their bug. They simply fire a query over ChatGPT, and ChatGPT is able to look out information through all these sources. It can go to Stack Overflow, it can go to Reddit, it can go to any other sources, and then curate up the information together and produce it to the user. So user is more likely to find all of them together, and in fact it can also give a citation from where this information was retrieved, which ensures there is a trustworthiness over the top of that AI model. Now, earlier, as I mentioned, if you have got a CNN network and you have trained it for some 100 objects, and you want another 100 objects to be trained on top of them, then either you need to start with all the 200 objects from scratch, or maybe you can try to have some kind of transfer learning and then you try to fine tune the model. But here, with the recent era of RAG and these models, it's actually just adding up that knowledge source. It's like plug and play. So you add a new knowledge source to your model, and it is able to identify what is the relevant information present in over there, right? Now that's where the fourth thing comes in, which reduces the needs or dependency on constant retraining. Whenever you have got a new knowledge source, you can go ahead, you can attach it to the existing model, and the RAG system will be able to refer it out. Now here we can see a typical example of RAG research assistant, wherein it's more relevant to our use case, since all of us do some kind of research. Now think of it like you have got some research article to be explored based on some area of research. So you will simply fire a query. Maybe in my case, I'll say semi-supervised learning. It will take semi-supervised learning. It will go through the information sources which are available, like Google Scholar, or maybe the SCI journals, maybe some other journals, and then it will be able to explore out what are the relevant information to this semi-supervised learning. Now it will curate that information and have the evidences as well. This will be given to your generator module, and generator will create a very nice sentences around it. This is an important one. This is the summarization of it. This model was being used, and how this is being getting better, like the accuracy F1 score, these kind of things. So it generates a very comprehensive answer with the citation to its evidence, which means from which source this has been retrieved, right? Through this, your research assistant is able to build a trust between you and your agent, right? The other example of RAG, it could be a chatbot, wherein it could be of a help desk. You go ahead. Earlier, we used to have that IVRS system, wherein you have to punch in numbers for speaking with customer sales, executive, press 9, and all those things. Now you don't need that. You go ahead, simply type in your query over there in this chatbot. It should be able to search out all the frequently asked questions, all the help docs which is available at its disposal, and then it should be able to identify what kind of issue that you are facing. Then again, it could be able to generate it in more simplistic manner, right? So if you can type in how to start a TV, and then it gives you some kind of predefined steps, then you can also give it like, see, my TV model is this, can you give instructions for that? It can go ahead, it can search for the new knowledge sources wherein it could be more relevant to your TV model, and then it could give you very precise steps on how to get your TV switched on, right? So it is able to generate very clear and accurate answers through this various knowledge sources that are available at its disposal. The other one, as an example for RAG, would be a summarizer, wherein there could be multiple source of informations present over there. I have
Hello.
depicted it. Yep.
Yes, sir. Good afternoon, sir. Sir, I want to ask one question. The
Mm-hmm.
previous slide, this RAG for a particular work. If we have a RAG chatbot for a particular work like hospital system, then in that we have to train it like how we train a small LM like a particular data set for hospital system. We need to train it on particular data like hospital data set or how like this
Okay.
for
So
particular.
you are considering that you are training a small language model instead of a large language model. Is it?
Yes, like that.
Okay, understood. So for small language model, there are various models which are available out of the box from Hugging Face. You can utilize it, and then you would be likely to do some fine tuning. It could be either you can do the whole fine tuning of your model, that small language model, but that is not very advisable. So the other thing that you can do is, instead of doing a complete fine tuning, you can do it like a zero shot or few shot learning. So whenever you are filing a prompt, you can identify the relevant information from that historical data, and you provide those as an addition to that prompt, right? As an example, like, see, this is the user question. I have seen these questions as in my previous history, and these were the answers that have been provided. So now your small language model should be able to curate up this whole information and create a new information out of it. Does that answers your question?
Okay, okay, okay.
So generally, I do not advise someone to go ahead and train a full-blown model on top of our data, because most of the times it requires very manual intensive work of cleaning that data. So you may have to look in each of the data items if they are complete or not, and if there is any incorrect or factual information present in the data, it might end up giving a wrong direction to your model, right? So instead of that, you should do something like a few shot learning using that prompt kind of thing, right? But if you are very confident that your data is clean and it should be able to train up your small language model in the right direction, then you can go ahead. There are various frameworks out there from Microsoft, from AWS, from Google as well, which helps you in fine tuning the models from scratch. Okay.
Yes, sir. Yes, sir. Got it.
Yeah, thank you. Okay, so now we have landed on to our third example of summarizer, wherein these blue and orange things are the documents, and these documents are going to some kind of database, a vector data store you can think of. And then the framework, the RAG framework, could be doing a summarization of these documents, which is going through some large language model. Through this, we are able to have a very compressed information of all these documents in minimum words, right? And it will be factually correct because you are already providing an evidences to all those information that has been provided. It may be very simple to processing a legal document, wherein if there is a clause and LLM is saying that your tenant is violating this clause, then it will also be supported with some kind of evidence of clause from these documents. So it's very effective, very useful. And then we are on to the last one from RAG, which is the final thoughts. So it's the best of both worlds from retrieval and generation. It reduces hallucination because it supports every information that you retrieve through some kind of evidence or citation. It is a way to generate a more intelligent, reliable, and trustworthy AI systems, right? Now, the question comes in. We have seen agents, we have seen retrieval, we have seen generation, we have also seen combination of retrieval and generation. And maybe you can put this retrieval and generation system for a medical help desk kind of thing on a single agent. But will that be really useful to serve in the n number of patients who are coming in? So the answer would be no, because the single agent may not be effective enough to service out all the requests which are coming in. And then the concepts comes from multi-agent RAG, which means that instead of having a single agent, we are trying to have multiple agents which are specialized in different tasks. Like one of the agent could be researcher, one of the agent could be analyst, and the other one could be writer. Now, in combination of these three, they could be able to create a single document which is very good in for the reading purpose and for the evidence purpose. But instead of relying on a single agent to do all three stuff, we are actually creating three different agents, and they are having their own specific set of goals. Now, again, the question comes in why there should be a multi-agentic rack. We already know that a single rack may be inefficient. We might want to avoid the potential bottlenecks, the difficulty in optimizing the information. And then through the single agent system, we are actually broadening its scope if we are applying more and more tasks to it, right? It may no longer be very specific to the goal. It may have very broad goals. Now that would may lead to some struggling of nonce analysis, right? That's why we want to have this multi-agentic rack. They are able to communicate among themselves, and they are able to solve a wider problem by defining the specific atomic processes in between, and each agent carrying out their own specific task. How it is being done? So there could be a key agents like a retrieval agent, which actually tries only to retrieve the information. Then there could be an analysis agent, which could be running analysis top on top of this retrieved information. And then there could be a specific generation agent, which could take this augmented information into it and then create some very understandable stuff out of it, which is natural sounding, coherent, and well structured. The process of it, you are asking a question, it goes into the system. There would be a routing mechanism which will fire the different agents which are at its disposal, like a retrieval agent. When it retrieves the information, it will go to analysis agent, and post that it could go to a generation agent as well. Now this could be a sequential process. There could be a parallel process as well, wherein there could be multiple retrieval agents looking out at multiple data sources at the same point of time. The advantages of it, it enhances the accuracy and reduces hallucination because each of the agent is having their specific set of tasks, and they are very helpful in tackling the complexity and specialize the expertise, because they are breaking down the whole problem statement into their own atomic spaces, right? And they have got very specific goal to achieve. So each one of them achieving their own goal leads to the overall success of that task. It also improves the efficiency and scalability because you can run these multiple agents in parallel, which can look at multiple data sources, which can do generation at parallel as well, or maybe finding an evidences to the retrieve information in parallel as well. The future of it, the potential application, it can used as to synthesize the information from diverse field. You may be able to utilize this multi-agent framework into hospital help desk system kind of thing. Then it could also be able to provide your legal analysis system, since they are having very specific task with their own personalization kind of thing. It could be used for customer supports as well, right? Now we come to the final part of today's talk, which is MCP, Model Context Protocol. Now think of it like there are multiple agents which are serving their own purpose, but they are not able to talk with each other in a common way, right? So it may be chaotic in first case. It may be you, if you can imagine, it may be a thing like everyone wants to build their own internet. So if I'm working on some other protocol, the other one is working on some other protocol, and we are not able to communicate in between, then there is no internet which is happening, right? Everyone is having their own set of systems, own set of networks, but they are not actually able to collaborate. So MCP gives you a way wherein you can collaborate with different systems out there, the different agentic systems out there. It is very specific to multi-agentic RAG, because in multi-agentic RAG only you are trying to employ multiple agents which should be able to communicate in between to help each other. Now, this MCP ensures that whatever the retrieval agent is able to find, it is able to clearly communicate it to the analysis agent. and then the analysis agent should be able to do an analysis and send it forward to the other agents like a generatic agent, generation agent, right? So these all agents should be able to maintain a context and a memory about it, right? What was the original query, what has been the overall progress of the task, what task has already been done, so that no other agent which are running in parallel should be redoing the same task. And this is what MCP ensures in the long run. So agents here, they should be able to understand the overall goal through the user query, the current state of the progress, what are the different individual roles to each of the agents, what were the past interactions that has happened in between them, and then there should be a shared knowledge base wherein they are able to communicate and retrieve the information from there, right? The key components to it, it should be able to give you a context encoding wherein they should be able to encode the information which are present in the same manner, right? It should be able to understand between all the agents out there. Then it should be able to do a context sharing, context updating. It should always be able to define specific roles to specific agents, and then the communication protocol should be unanimous across all the agents which are working together. The key components, since we are talking about context sharing, context updating, there should be a shared knowledge base or memory. Then we are also mentioning that it should be able to communicate, hence it should be able to pass message to each other. Then we should be looking into the past interactions, so there should be a state tracking mechanism. The roles and responsibilities, it should be able to align and assign them. Then there should be a synchronization mechanism which should be able to allocate the jobs across all the agents which are working in parallel together. The advantages of it, it improves the coherence, which means that the agents are now ready to work together in a more effective way. It reduces redundancy because each agent is aware of what the other agent has already been completed. Enhance the efficiency because each agent is knowing that what other agent is doing, so it is able to either being dependent on it or maybe running a task parallel to it, which actually gives more effective results in the final manner. Better decision making, since the agents are knowing about each other's roles and tasks, they are able to curate information and take in the best decision out of it. And this also helps in increasing the robustness because the shared system, the unanimous protocol that they are talking with, it reduces the chances of failure, or in even in case of failure there could be a replacement agent on top of it. So this increases the robustness of the system. Now the conclusion of the talk, I would like to conclude it with it's the power of collaboration, which means that if the agents are able to collaborate in an effective manner, then they are going to be producing more effective, more accurate, and more efficient results at the end of the day. Thank you, Dr. Joshi, Dr. Mishra. uh, i I have completed